This is going to be the shittiest PowerPoint you've seen in a long time.
Well, in that case, I'm just going to leave it split wide, and that way you're more than likely to be in it long as you're like between the screen and.
Perfect. Perfect. That's great.
And we're going now.
All right. Hello, everybody. This is the HTML5 security. I'll go ahead and get started. I think I've got like 50 minutes or something. I typically will run over on my slides. So like at the very last slide, there's a thing that says questions. But I'm probably going to run over that. So if you have any questions while I'm talking, just throw up a hand or just shout out a question. I'd be happy to like engage with you and back and forth. Please don't save any questions that you have till the end. If anything bugs you, if you don't understand it, if I start babbling in jargon that you have no idea what it is, stop me. I'm happy to explain myself. I'm an application security expert, so I work in a sort of a niche part of security that sort of delves into a lot of specifics of application development. And I sometimes forget that a lot of the stuff I'm talking about doesn't make sense to a whole lot of people. So I'm sure everybody's had that experience where you start talking and you get the point. Look, so stop me. You're just like, what? Wait, what did you just say? So I'm Justin Klein-Keane. I work for the University of Pennsylvania as an application security specialist. I also help run the Philadelphia chapter of the Open Web Application Security Project. I presented at this conference and other conferences a couple times. I think technically I'm an adjunct professor at Drexel. I'm writing a book for No Starch, and I got a bunch of other qualifications you probably don't care about. I'm here to talk about HTML5 because I feel like this is an advancement that's really creeping up on all of us and on the entire industry. And I think there's a lot of really phenomenal stuff that's happening with HTML5. And I think when HTML5 was first announced, the InfoSec community sort of decried it, said like, it's just going to be another pile of shit. Nobody's going to use it, and it's going to give us new ways to break into stuff. The last part is true. The other stuff, debatable. So there's actually a lot of really good stuff that went into HTML5. When the committees sat down and tried to design HTML5, they actually had people on those committees who knew something about security and knew something about privacy, which was completely brand new. And so there's some neat features in HTML5 that you can actually use when you're developing an application to make it sounder, make it safer, make it more secure. So the developments in HTML5, while they're attractive to developers because they can stand up their cool app really quickly, they also should be attractive to security groups because then you can talk to your development groups and say, hey, are you using the new security features in HTML5 to do X, Y, or Z? And so I'm going to try and give a broad overview. HTML5, it's a moving landscape. It's a really big topic. I'm just going to try and cover the kind of stuff that I think you'll probably hear about or you may or may not be interested in, just to give you sort of a better sense of what's going on and some of the things that I find particularly fascinating about HTML5. So first of all, just a show of hands, who has heard of HTML5? Awesome. All right. So who feels like they know what HTML5 is? All right. Okay, yeah, that's pretty typical, right? So everybody's like, there's this thing out there, and it's, I don't know, whatever, we'll see it when we see it. The reality is you're seeing it right now. So I don't know if you've ever been browsing around on a website and you get a little pop-up in your browser that says, like, so-and-so site would like access to your geolocation data. Would you like to allow? And you're like, that's an HTML5 tag. That's a feature of HTML5 built into your browser. And you'll increasingly see this type of stuff show up. I was trying to read an Amazon book on, like, their Kindle Cloud Reader yesterday, and it was like, this application would like access to offline storage on your system. I was like, wow, that's a new one. I hadn't seen this one used before. And, so you're going to see this show up over and over again, and I think it's really going to change the way that web applications behave, the way we interact with web applications, and specifically how we test the security of web applications, because a lot more is going to be possible. So I'm going to point out some of the more popular features, some of the ones you'll hear about. I'm not going to cover the ones that are strictly attractive to developers, just because I don't think that's really going to be of interest to you all. You can make cool canvas elements and stuff, whatever. There's a new security model implicit in HTML5, and this is a totally new thing. HTML4 had a security model, but it was kind of like an understood thing, and you didn't really have to abide by it. There were some restrictions that were set in stone, but most of it was just sort of by the wayside. Some final thoughts, my take on HTML5 security and where I think this is going, and then some questions if you haven't already had questions leading up to that point. Let me know if you can't hear me, by the way. I'll try and speak loudly so the folks in the back, but can't hear me. Know about that too. So normally I have my slides here and my slides here, so I can just look here and see what I'm saying, but my display's all messed up, so that's why I'm glancing over my shoulder here. So at its core, HTML5 is just a markup language, right, that we use to tell a web browser how to render a particular website, right? And so there are three core technologies right now that really sort of make up HTML. You've got your HTML, you've got JavaScript, which adds some dynamism, and you've got some CSS, which does dynamic display. And the important thing to remember about all of these is even though the web application developer is the one who sort of writes this stuff up and sends it to your browser, your web browser is the one that actually processes it and makes this do stuff, right? Like nothing happens server side, this stuff all happens client side, and as a result, the way that Internet Explorer renders a page can be different from the way that Google Chrome renders a page, because it's the client that's actually doing these kinds of rendering. So at its core, you've got these three technologies, HTML, CSS, and JavaScript, but in sort of the old HTML4 style of the web, and I'm sure you're all familiar with this, that's not all. Then you have sort of this like truckload of plugins that you add onto your browser, like your PDF displayer, your Flash player, your QuickTime display thing, your Java web plugin, your DivX codec or whatever. And I'm sure anybody, if you go in your web browser and you sort of take a look at the list of plugins, you'll kind of be horrified how much extra stuff is in there, right? And all of that stuff is sort of developed by a third party who doesn't really have any strong affiliation with the browser manufacturer. It's not very trustworthy. It's extremely error-prone. Anybody that's followed vulnerabilities and these kinds of things knows that like Adobe vulnerabilities are just like every month there's like more Flash or Reader vulnerabilities. These all manifest in the browser. And so you sort of have this dual situation where developers are having a hard time because they're trying to develop a web application. They get to a point and they're like, man, I really wanted an animation here. And they're like, okay, who knows Flash? Ah, shit, nobody knows Flash. Let's run and find a Flash developer. Flash developer shows up, does some magic. Web developers have no idea what went on behind there, and they package it all up and ship it off. Now, use the web viewer, you pull down the website, and you're like, well, there's a big blank hole right here, a little thing. You click on it, it's like, you must install Adobe Flash. And you're like, ah, crap. And everybody's frustrated by this situation. And so the developers of HTML5 sat down knowing this. And they said, you know what? We should develop the kinds of popular stuff that people want to do in their web browsers native in the web browser. So like playing a movie. Your web browser should be able to do that without downloading a plugin. Playing a sound. Your web browser should be able to do that without downloading a plugin. Validating a proper date field in a form. Your browser should be able to do that, and currently HTML4 can't. So these were some of the design elements behind HTML5. It was basically to get rid of a lot of this cruft and sort of expand the capability of the three core components, HTML, CSS, and JavaScript, to handle a lot of the stuff that those plugins do. So because HTML5 is browser implemented in the browser, it's suffering a lot of the same growing pains that JavaScript did early on. So I don't know if anybody did any JavaScript development like 10 years ago, but you basically had to do this like 200 lines of browser detection and like, right, this JavaScript goes for IE, and this JavaScript goes for Netscape, and this JavaScript, and it's just an ultimate hassle. You're running into sort of the same kinds of stuff because the spec for HTML5 is being produced by the World Wide Web Consortium, the W3C. I love this. The guys who are up all night are falling asleep already. So they're developing these specs and basically telling people like Google, like Microsoft, like Netscape, not Netscape, but Mozilla, these are the kinds of things that you should implement in your browser. And these are the specs for the implementation, but they don't specify how to actually implement this stuff. So some browsers are really good at implementing a lot of really cool HTML5 features, and some browsers suck. Ironically, or maybe not, mobile browsers tend to be the best at implementing HTML5 features. And I think it's probably just because they're moving the fastest, and it's easy to update and replace stuff on the mobile platform. But guaranteed, your smartphone or your tablet will almost be completely HTML5 compatible right now. You're not waiting for features on that. So in the end, what we're trying to do is we're trying to erase the headaches of plugins and ultimately allow web developers to make applications that look exactly like desktop applications, right? So we're trying to extend the power of desktop applications to web developers. And sort of the canonical example of this, the HTML5 guys, they want to be able to program a full multiplayer, first-person, three-dimensional shooter in a web browser. I've actually seen a demo of one. It's pretty sick. So they're adding functionality to your web browser to do that kind of stuff. And you just kind of think about what you would need to make something like that happen in a web browser. And we'll go through some of the technologies that they actually use to accomplish that. So interestingly, this is actually pulled off the W3 org site, but this is just like the first time I've really seen sort of a warning like this in a spec. Basically, the people who are working on these specs recognize that they're greatly extending the power of HTML and web applications, and if developers aren't careful, bad things will happen, right? So they're sort of doing their best about saying, like, if you sort of use some of these features, there could be privacy implications. If you use some of these features, there could be security implications. And people have actually done word counts of the HTML5 spec and counted up the occurrence of security and privacy, and it's actually like dozens. Like it shows up. So the people involved in this project actually care and have been very responsive to early feedback from the InfoSec community that HTML5 was a train wreck. So here's some of the new stuff that HTML5 adds. You get new HTML tags, and they're sort of like semantic-based tags for stuff that like we see in web pages over and over and over again, but web developers were basically having to hack their way around. So we have tags like article. You have new dynamic tags, like canvas is a dynamic tag and allows you to draw a canvas that you can put then dynamic vector graphics on top of that canvas and then change them and stuff like that. And then there's new features that are implemented in JavaScript. So they're an extension of DOM, elements and functions that you can use. So, you can now do document.register new tag and actually create your own like made up HTML tag for whatever kind of content it is, which is actually nice because it makes your HTML look beautiful and not like just a soup of div tags all over the place. You can test for new features, like window local storage. That's an offline data store that the browser can then access, assuming that this function doesn't return null. And then this one is the one that causes that pop-up, do you want to show your geolocation with this website, navigator.geolocation.getCurrentPosition, and this will do its best to figure out what is your GPS coordinates based on your platform or based on what Wi-Fi you have access to or whatever else the platform can tell the browser. And of course, this is all sent back to the server. That's not something the browser is generally concerned about. So these are sort of the popular features I'll just gloss over. This is the kind of stuff that your web development department is going to be like, oh, this is the coolest thing ever, and come to you drooling and want to use this stuff for. So you can do dynamic drawing, right? So you can do your animations actually in HTML, which is actually frighteningly cool. You can do video and audio tags without having to hassle somebody about having their plugins. You can automatically play stuff. There's tags for specific type of content, which the semantic web people are going crazy about. They're actually going to be able to find calendar events on web pages finally, things like that. There's new form controls, stuff that people have been hacking around with JavaScript for the long, like a calendar pop-up when you have to enter a valid date field, like it's maddening that people still have to code their own solution to that. Like it's so common. Or like enter your birth date. Well, okay, how many different formats are there for birth date? And there are going to be new form controls that'll basically pre-validate that. My favorite is email address, right? The browser will validate that you entered an email address, which is awesome. Still doesn't mean you can ignore that stuff on the server side, but that's going to be really helpful. There's going to be a neat little interface for client-side form validation. So if you fill out a form and it doesn't pass the client-side validation, the developer doesn't have to write that validation. The web browser itself says like, oh, hey, you accidentally missed this field that's marked as required. It'll sort of shift your focus back up to that field. And so this is going to be really handy and strip out a lot of the crappier JavaScript code that you see in web applications. There's a new history API. Ooh, bad, maybe, I don't know. And there's new support for drag and drop functionality so that you can do more dynamic web applications. Is there a question or people just waving their seats? So now I'm going to sort of talk about some of the new features, and I'll sort of cover what they're intended for, and then what they're not intended for, and I probably see problems showing up with them. I'm going to cover the heavy hitters. So these are the ones that you're going to read about in news releases or magazine articles that say HTML5 is coming and the sky is falling and whatnot. So one of the biggest ones is web storage. So this is a new way to store data on the client. So traditionally, if you wanted to store information on a client about like a web user, you had to put a cookie on their system, which is fine. Cookies generally organized as key value pairs. It's just a text string, but the size of a cookie was just a couple K. You couldn't actually stash that much stuff in a cookie. Not only that, but it was really easy for a user to actually go and read their cookies because they were just stored in text files. And so you had these situations where developers would like hash the values of their cookies to like hide them from end users so you don't know what anything is. With offline storage, the spec says that the web browser is going to basically be able to use these JavaScript calls to either populate a NoSQL style database that is a key value stored database or pull data out of that key value stored database. And by default, they're just choosing an arbitrary limit of 5 megs of data that they'll be able to stuff into this data store. So that's a pretty amazing amount of data that they'll be able to put into this offline data store. And at first glance, you're like, yeah, why would you want to do that? Well, the whole point for this kind of web storage is for offline browser use, right? So like you're typing in Gmail and all of a sudden your Wi-Fi goes away. Gmail will say like, well, we're not going to lose any of your data, just let me store it locally. And then when you reconnect online, I'll go ahead and sync your local store back up to my major store. The other thing that is helpful for developers is if you have to pass a lot of data back and forth between users, like say document editing, you have to like get a copy of the document, send a copy of the document, get a copy of the document. You can now just store a full copy of that document locally and then just do deltas in between the server to keep everything in sync. So this is going to be super helpful for the developers in terms of like pushing a lot of data down to the client, offloading all of that network interconnectivity, and all of the computation that's going to have to go on. Yeah?
Where do you have an idea where they're going to store it?
They're going to store it on the file system in a directory per web browser, and it should be a directory per domain. So access to these stores is by domain, so by URL. And the browsers that are supporting it now are using NoSQL databases. So there's just little NoSQL databases that you can go find, which are totally inscrutable to regular people. But if you know anything about NoSQL, you can just like pop it in a NoSQL shell, and you're like, hey, look, I can see everything. Yeah, when I pulled up Amazon and they were like, do you want to store stuff offline? I was like, hell yeah. Like, let's see what you give me. How much copyrighted content will you put on my machine? I didn't get a chance to check that. So yeah, so there's also this web SQL database. I'm just throwing it out there because I don't know what will happen. This was a spec where basically they wanted to have a full relational database management system in the browser with like multiple databases with user access control and like multiple tables and stuff like that, different table definitions. So far the spec has not been updated in a little while and it looks abandoned, but you know, just keep it on your radar. That might rear its ugly head again because that looks like a horrible complex mess. So from a security perspective, offline storage I find like super exciting because now I can do SQL injection on your client. I can do invisible SQL injection because the server will never know, and I can do things like pull stuff out of your data store that you didn't mean to have pulled out of the data store, that the developer didn't mean to have pulled out of the data store. I can also do persistent cross-site scripting by stuffing malicious JavaScript into your client-side store, right? And then, likely, the web server, the application developer, will never have any idea that I just attacked their users using cross-site scripting because I can now store all this stuff client-side, which is a lot of fun. Also, I think this is going to be an interesting target for malware, right? Malware might hide itself in these offline data stores, but what's more important is more and more web applications are going to start using this offline data store, like your bank, like any other financial institution. And now malware is going to have easy access. It used to just be a couple K cookies stored information about whatever it was you did on this website. Now you might have 5 megs of data about what you did on this website. And if you get some client-side infection, I guarantee some early variants are going to start hoovering this stuff up and shipping it off. Yeah.
Do you have to still hold the storage scope the same way cookies were as far as subdomains and things like that?
On the file system, it's scoped to the user.
Scoped to the but star.google.com or mail.google.com?
Oh, yeah. In terms of domain-based access to the other, it follows the same domain origin policy that is used in JavaScript now. Yeah. Although there's a complexity to that. There's a quirk that subdomains shouldn't be able to see each other's data, but with the new history and domain API, you can actually wipe out subdomains and force 2 subdomains onto a superdomain and then steal data across them. So you should not consider separate domains, separate subdomains as separate compartments anymore because it's easy to evade the protections there. But yes, it's supposed to be stored. And then on the file system, this is all right. This is all just owned by the user, right? So any user, client, malware, it has access. Anybody that can log into the computer has access to all this stuff.
When this gets released, it'll be encrypted.
Of course,
yeah.
And nobody will ever store a credit card number in it. What's on the client side, right? You're not taking it from them or anything. Actually, what's terrible is the mantra for application security developers has become, don't store anything sensitive on the server, right? We don't want to take a risk of losing it, and we don't want the liability of having to like do a press release and say like, oh, we got to do credit monitoring, we lost your encrypted password, blah, blah, blah. And more developers are trying to push sensitive data down to the client and basically say like, it's on your computer, you're freaking responsible for it. Like, if you get a malware infection and it steals your password to Citibank, that's not our problem. Like, that's your problem. So no, it probably won't be encrypted because it's like, why? Like, we'll see. We'll see. I also think forensic analysis and forensics analysts will love these offline data stores because now you're just going to get not just like these little breadcrumbs about websites that people visited. You're going to be able to get a volume of data about what somebody did on a website. Say in the case Gmail starts storing your email offline for easier access. Well, now a forensic analyst, they get access to your Gmail offline, right? This is going to be amazing. And it's really, it's just a matter of time before we figure out how people start misusing this and causing issues. The other big issue, which you alluded to, is that the trust or the security barrier to these data stores is per domain, right? Not per IP. So if you could spoof DNS, you get access to anything you want, right? So this is all, the security model hinges on DNS, and if a DNS server is compromised, all bets are off. You can grab anything you want, you can push anything you want. There's not really a good solution to that, but so yeah. So down there is the link to the actual documentation if you want to read it. It's kind of dry. This one is really cool. So they want to actually have an offline file system for the web browser and the web application. So this makes total sense, right? If you're building World of Warcraft online, you want like a folder that has your equipments, and you can store files in there, and a folder for like your sounds and your pictures, and you can munch this all together and make a really cool game. Security person in me says like, wait, I'm browsing to an untrusted or unknown third party, and now they're executing code that's storing stuff on my computer of like undetermined size, format, or like I don't. Like, I admit, that's such a sick person. The first thing I think is like, what if somebody sets up a website that just pushes kid porn down to everybody who visits them? Like, right? Like, what can you do about that, right? You suddenly now, if anybody forensically scans your computer, cry. Yeah, well, I guess. Yeah, this is horrible. Or maybe the lesson is just to store all your sensitive stuff in one of these offline web stores and say like, I don't know, I didn't put it there. What's it? So the API in HTML allows you to upload and download files. It allows you to establish usage on the file system. Apparently, you're supposed to ask the user before you do this. You're supposed to say, this website wants 5 megs of your local storage in here, and if it increases that, it should ask you, this website wants to, you know, take 100 megs or 100 gigs off your file system, whatever, start storing stuff there. You're supposed to know, so, yeah, nothing is ever going to go wrong with this, right? I love that people can already see, like, this is going to go sideways. So you've got denial of service, you've got theft of this data, right? I mean, you have one directory traversal screw up in a browser, and then one site can grab stuff from another site and export it. Who knows? There's no controls over what kind of data is going to get stored here. Obviously, the web developers are going to assume that the security context is that of the user account logged in. I don't know what that happens on a multi-user system, especially when somebody has admin. You know, who knows what's going on there. I also thought it would be kind of fun to spread my malware by putting it on my website and just asking you, like, hey, would you give me like offline web storage, and just stick an exe down on your computer and wait and see what happens. You know, maybe you go through and click it. And then, of course, the dangerous and illegal file systems. You know, there's no controls over this, and after the application asks for your permission to store stuff, it doesn't tell you what it's stored. There's no easy way to get a manifest. In reality, you can find the root directory for the domain that this is being stored. It's just like the offline database, and you could take the time to go through it. It's probably only a matter of time until some enterprising Firefox developer puts a plugin that says, like, show me my offline data stores or whatever. But WebSockets. So one of the pernicious problems of current, like, Ajax-y web applications is you have these web apps that look like they're doing this constant back and forth with the server, right? So you log into Google and you can sit there and chat with people, right? Well, that's not a bi-directional communication, because actually HTTP is stateless, right? So what's ended up happening is the developer, very simplistically, has written a JavaScript loop that says, like, wall1, poll the server and ask if they've got anything. And this is incredibly wasteful from a bandwidth standpoint, from CPU standpoint, memory standpoint, because you basically got a client that's just constantly polling. And so WebSockets was developed to create true bi-directional connectivity over HTTP. So you're going to see these two new protocols, WS:// and WSS:// extra S's. Sounds for secure. So this will use port 80, and this will use port 443, and it will be a totally bi-directional communications channel. So you'll be able to connect to a remote service and just sit and wait and set up event handlers for listeners and just say, like, oh, hey, my friend just sent me a new IM. The server just told me, so I'm going to pull it down and I'm going to render it. Now I'm going to write my message. No, I'm going to send it to the server. And therefore, we're only taking up that back and forth bandwidth. So this seems pretty benign. And, you know, the server will validate client requests because they're all supposed to send this little nonce, this little token. And if you don't have the secret password, it just tears down the connection. The first thing I thought of when I saw this was like, this is going to be gold for data exfiltration. I can maintain a persistent connection over port 80 and just pump data through it. Not only that, it's designed for that, right? So your next-gen firewalls that look at this HTTP connection that's like, dude, somebody's maintained an HTTP connection for 48 hours. We should probably tear that down. That's what this is designed to do. It's designed to sit open for 48 hours and send data at like different intervals, or just send data constantly. This is going to be the best way to get data out of an organization under the wire. And always use this one too if you don't want people to see what you're doing. Right? So that's all encrypted with the WSF. So this is going to be really interesting. Luckily, it's bound to port 80 and 443, but it's going to make interesting denial of service conditions if you're running these sort of WebSocket interfaces. If you got somebody like connecting over and over to them, you could crash them. And the other thing is there's no implicit security in these WebSockets. So these are a little bit like they're kind of soapy in their infancy, right? So this is basically a place where you can send me data and I can respond to your data, but it's up to the application developer to determine whether or not you're authorized, have valid access, whether you're doing something bad. And I don't know, based on my experience, like nobody's going to do that properly, right? It's going to take a long time for somebody to figure out a good way to do that, federate identity, do that kind of stuff. And so I'll bet you, the first time you pen test an application that has one of these interfaces, you're going to be able to send data and get data from it with absolutely no authentication. You're just going to have to know the magic nonsense. Honestly, the application is going to give that to you. So you'll just be off to the races. So vector graphics, super cool. This is a big seller, right? You can draw all sorts of dynamic pictures and actually make dynamic movies, like full dynamic movies. And this is heavily used in the sort of the online gaming demonstrations. You do these online SVGs or SVGs. They're awesome for scalability, for responsive design, right? Because now you're defining your graphics in terms of points and vectors, and so like the pixel length doesn't matter anymore. You're just basically setting up the angles and plotting in the colors. So you expand it to like a huge display like this. It looks crisp and sharp. You shrink it down all the way to a mobile phone. Still looks crisp and sharp. This is gold for designers. And it eliminates a lot of the need to embed complex graphics. It's also a lot lighter, right? You just send a group of coordinates down to the client renders it rather than having to send some sort of compressed binary down the line to the client. From a security perspective, I think this is awesome because now I'm going to be able to draw canvases that cover the entire screen and then put whatever the hell I want there, right? So clickjacking is like this darling attack where I trick you into clicking on stuff that you don't know what you're clicking on, and I'm not aware of any attack in the wild that has ever taken use of this, but like, you hear it over and over again. Like, it's an exciting attack. With HTML5, it's going to become practical, right? Because as an attacker, if I can find one arbitrary script injection flaw on your website, I can inject a whole new canvas that covers up your screen, that reacts, that gets you to click on stuff, that sends stuff back and forth, and all sorts of nastiness happen. There's also been a couple proof of concepts already that could show that, like, if you send somebody a malicious vector graphic, you can crash their machine because, basically the browser starts to render something and realizes it runs out of CPU, and boom, you're done. I'm not quite as interested in those. I think the clickjacking and sort of the fraud and cross-site scripting angle is a lot more interesting. Web workers is another space to keep an eye on. So web workers are basically, they're spawned in JavaScript, and they're threads. So has anybody here done multi-threaded programming? A few people. All right. So multi-threaded programming is like the most error-prone type of programming ever. Like it's almost impossible to get right. Like basically what you're doing is setting 10 people up in a line, and you're saying like, go to that wall. And then now as they start off at different paces, you start asking them to talk to one another about what they know, what processes they calculated or whatever. And you can see the logistics of this challenge. Like, I don't know if that guy even started. There's no communication between them, really. And then you expect them to get all to the wall. Now, if they're not supposed to communicate or do anything amongst themselves between the time they start and the time they get to the wall, so like if you're doing multi-threaded, like SSH brute forcing, then it doesn't matter. Like, who cares? Then I just got like 10 walkers, and as long as they get there, like, cool. But if they have to talk to one another and do the kinds of things that you do in a dynamic web application, the state is going to fall off. You're going to run into unexpected conditions where workers have died or gone away. And not only that, a worker is going to collect some private information and not realize who has access to it. And so there's going to be a whole new multi-threaded attack surface in web applications. It's really easy to start these things in JavaScript. It's really difficult to get any type of multi-threaded programming right. So I'm not aware of any specific class of vulnerability that's going to affect these things, but you're definitely going to find problems with these web workers. There is some attempt to keep web workers from sharing data in that they can't share data directly, but it's really easy to end run that by setting up anonymous listeners on like the spawning page and having the workers kick messages back to the spawning page who can then share them back out. Basically, anytime you see a web worker, you should scratch your head and say, like, I don't know, I bet nobody thought this through. So the new security model for HTML5 is an evolution of the old HTML4 same domain origin policy, which, how many people have heard of same domain origin? A few people. Okay. So the idea of same domain origin in a nutshell is if I create an HTML page with like 2 frames, and one frame is like Google and one frame is CNN, none of the JavaScript on the CNN page should be able to access anything on the Google page, and vice versa, the Google page should not be able to access anything on the CNN page, right? And by doing that, we have situations where like you can't get a page with frames, with 2 separate pages where one page is like manipulating maliciously the stuff on the other frame. Like you can't cross that line. This is hell for people who want to make mashups, right? So people who want to present you a site where they, pull Craigslist and find couches in your price range and then plot the little pins on the Google map, that becomes really difficult if you can't just get Craigslist and Google to actually pass messages between the domains. So because of that, the HTML5 introduces this new security model called cross-origin resource sharing, where you'll basically be able to allow certain domains to access data in your domain, right? So that now if I wanted to go into a collaboration, between Google and Craigslist, we can relax that same domain origin policy and say, you know what, between the 2 of us, it's fine. You can share stuff over the browser. What terrifies me about this is there's a whitelist flag. So you can say, trust everybody and everybody. And like you're done. And guaranteed people will do this when they start testing. They'll be like, trust content from whoever. Like we'll just make it work and then we'll apply the security, right? And that never goes wrong. And so now my web application, I can frame it in and I can grab data from inside your other web application. I can exfiltrate data. And so what that means is if you pull up my website, mattirish.net, and gmail.com, and you're logged in, my mattirish.net site can now go in and grab your cookie token from gmail.com and just pull it right back out because of the same domain origin policy has been relaxed over Gmail. Yeah? You can test for where? Oh. I'm sure it'll catch this, yes. But this is a terrible thing. This is all happening in the browser. So nothing is going to check any of this. Nothing's going to find any of this. And nobody's going to notice anything strange going on. And it's because HTML, by its very nature, is kind of a mess. Like, even right now, although we have sort of this cross-domain origin barrier that we're trying to set up, every web page you visit draws resources from multiple different locations, right? You get the HTML from one place, you get an image from another place, you get a JavaScript file from another place, you might get a style sheet from somewhere else, you might get another snippet of JavaScript from Google or DoubleClick to track you, and that's stuck in the bottom. And we're already doing these mashups. The thing is, right now, you supposedly are supposed to get all of those resources, marshal them into one place, and then they can sort of send stuff back out, but they can't reach anywhere else. Their origin then becomes the resulting page, and they're sort of stuck in that little box, and they can't go anywhere. So at first glance, this cross-origin policy seems like really terrible, and they actually sort of point out that you shouldn't use the domain as your boundary because it's manipulable. And so this sort of sounds like the sky is falling, but it's not. Because there's also this content security policy, and if used properly, could actually eliminate all cross-site scripting on the web. I don't know if that's ever going to happen, but if it is used properly, it can. And the reason is, web applications can set up in a new defined HTTP header in their response to clients a content security policy and say, the stuff that's going to follow in this HTML page must follow these following rules, right? And some of those rules say, all of my content will come from the following domain. All of my fonts will come from the following domain. All of my frames will come from no domains. You get no frames. If you find any frames, ignore them. All of my images will come from the following domains, so on and so forth, right? And so you can write up this sort of like menu and sort of a la carte, very carefully pick and choose. And one of the things you can say is you can use a default and basically say everything is coming from me. If you get any resource that's not coming from this domain, just ignore it. And your browser literally will just ignore it. It'll ignore any reference to any of that. And one of the really cool things that they have is you can use inline JavaScript restrictions. So, and that follows off of the content source. And you can basically say, only JavaScripts will come from me, and only JavaScripts from me that are properly architected. And what this means is that if the browser finds any inline JavaScript, like any script tags, it just ignores it. Everything in between there totally ignores that. So if you actually set up your site using these headers, it can have cross-site scripting vulnerabilities all over it. But any of your users who come in and visit with an HTML5 compliant browser will not be affected by any of those. So the browser will proactively say, I got a security policy that says it shouldn't be here, so I'm not going to do it. The problem is, if you enable all this stuff, all your existing web apps are going to break. So what everybody's going to do is they're going to start out with these content security policies, and they're going to use these two things here. Say, oh yeah, it'll only limit stuff from here and stuff from here, but also enable unsafe inline JavaScripts and enable unsafe evals in your JavaScripts. And this basically breaks down all the JavaScript protection, which is really bad. And part of the reason they're going to do this is some big libraries like jQuery that power a lot of the dynamic stuff on the web use unsafe evaluation. And so until those libraries can fix their code, you're never going to see a way where everybody can turn all this on in a feasible manner. It's also going to be a hassle because people are going to have to re-architect their web applications. No more like just sort of sprinkling Java into your HTML or JavaScript into your HTML. You're going to actually have to take all that out of your HTML, put it in .static.js files that don't do anything, that then must be included by the page, and then you're going to have to do stuff like register event handlers, register onload handlers, fire off events explicitly, that kind of thing. And that takes a lot of work, and there's a bunch of architectural overhead to creating an application at that point. It's the right way to do stuff, frankly, but people will probably resist it. So this is one of my favorite parts about the content security policy is they enabled reporting. So you can set up on your server a reporting URI that'll just sit there and listen. And what it's listening for is JSON objects, so JavaScript object notation objects. And when a web browser denies the display of an unsafe whatever, denies the rendering of anything that violates the content header policy, the client will actually send your server a report saying, client so-and-so explicitly denied this script alert XSS from this application at this location on this time. And so in this way, this is really one of the very first ways that application developers are actually going to be able to detect and track cross-site scripting attacks on the clients of their application. And so this is super, super cool. I think it was designed for debugging to basically say like, my website's not working. Why isn't it working? Well, you go look at the reports and you're like, okay, I see why it's not working. But what's really neat is if your website is working perfectly and you get like 1 or 2 or 3 of these, you can say, oh my God, somebody's trying cross-site scripting attack against our users. They're trying to steal the cookies. Let's figure out who these users are. Oh wow, they're all sitting in the same web cafe. They're all using the same insecure wireless. Like, okay, well now I've figured out somebody's using Wi-Fi to attack my application or whatever. And so in sort of the InfoSec triad of protect, detect, response, I think this is a really neat addition to HTML5. And I would strongly encourage you, if you hear of anybody developing HTML5, say, oh, are you doing the content security policy reporting part? And you'll probably hear no, but you should encourage them to do it. It's pretty simple. There's also new security models. You can sandbox certain elements of your application, basically make them invisible to other elements of the application. You can do stuff like you can sandbox iframes to known malicious sites, and it'll actually work sort of in the same way that the Chrome's like tab sandboxes now. Those places are totally inert. They cannot execute script across one another. You can sort of like safely plug in like really bad content, or if you need to use, say, like a bad plugin somewhere, you could frame that plugin in and set it into a sandbox mode and effectively run it in a much safer way. This is another one of these huge advances in HTML5. Of course, HTML5 introduces a lot of new stuff. And every time you get an increase in complexity, you get security vulnerability, right? People aren't going to know how to use this stuff right, and so they're just going to play around. You're going to have a lot of people copy-pasting from, Stack Overflow or whatever and say, like, I got it to work, and then everybody uses the same vulnerable code. I mean, when I did app dev in the very beginning, that's exactly what I did. I look back and see my old code, and I'm like, geez, there's like SQL injection all over this. But it worked! So, it's pretty frequent that the app developers are going to move to the coolest, latest features, and every time they see one of those little boxes that says security warning, they're just going to skip right over it and just keep reading, right? So it's going to be our job to sort of like look for those security warnings and try and find code that matches those sorts of criteria. The other thing that I think is going to happen is a lot of like testers of web applications, a lot of testing tools, they're not going to be familiar with this new functionality. They're not even going to think to review it or look at it, right? So I think automated tools are going to miss a lot of this stuff for a long time, and I think a lot of testers even, they're going to look at it and just say like, well, that looks a little bit weird, but sort of familiar, and just skip over it. Won't even bother, say, looking for WebSocket ports on an application. So I think we're going to have sort of a honeymoon phase where people are producing insecure web applications and nobody's noticing it. Right? It's going to take a little while for somebody to say, oh my God, wait, we've been producing insecure web applications for the last 4 years with HTML5. Also, you know, a lot of people use these third-party libraries to do a lot of this complex or dangerous security work. It's going to take a while for those libraries to adopt HTML5 standards, especially when faced with problems of backwards compatibility. They're going to be a little bit slow, right? They're not going to want to say, oh, hey, we updated the latest version of like jQuery or whatever, and now it's all HTML5, and sorry, you're running IE6, your app doesn't work anymore, or anything like that. You know, and that's exactly where they are with the unsafe evaluation right now in jQuery. Oops, away. So I think the landscape for sort of attack methodology is going to change, because there was sort of like traditional strategies that attackers use to sort of like exploit cross-site scripting, cross-site request forgery, SQL injection, you know, like arbitrary code execution, like the laundry list of stuff that you do. And, you know, if anybody goes to the library and bookstore and buys the whole like SQL injection cookbook or whatever it is, it's like 200 pages of like different characters you can throw in. Same thing for cross-site scripting. All bets are off now, right? Because now you're going to have new means of interacting with the site. You're going to have new sort of elements in JavaScript that'll allow you to trigger events that maybe your old like HTML5 Purify libraries would strip out everything except for the new JavaScript form action, right? Just because people don't know about it and they don't know about browser support. So I think there's going to be a small window where we're going to be able to carry out classic attacks using new vectors, using the HTML5 compatibility that we get. And my two favorite are the do geolocation, get current position. Like, I love that like now I can have a web application that tracks your phone and figures out where you are, and it's just frightening. And the other one is you can use get user media to turn on the microphone and the camera on someone's device. Like, that's awesome. That's super cool. You're visiting my website and I'm visiting your bedroom. All right. Thank you. I actually finished on time, maybe a little bit early. So did anybody have any questions? Or? What?
Vulnerability scanners, are they keeping pace with anything new?
I think there may be some vendors here, so I'm not going to speak ill of vulnerability scanners. I'll say this, I don't own any vulnerability scanners. I do all my scanning by hand. So probably. Yeah.
Are there any final dates in mind? Or?
No, right, so the W3C is just a consortium, so really when they propose a new feature, a browser might pick it up or they might not. And so you can find a lot of good sites that'll sort of show adoption of HTML5 features. Early on, like Opera made this like sprint, like they just like supported everything, and some, you know, crazed attempts to gain some market share, and they've kind of fallen off. Right now, it looks like Firefox and Chrome are the two best ones for supporting most of these features. And Chrome, I think because of their release cycle, is much better about picking up new features and running.
They're kind of where they're going to draw a line in the sand and say, okay, this is HTML5 and
nah, well, they might, but I'm sure that's going to be a committee thing, so there's probably going to be like a big battle about that. Yeah, right now everything is sort of listed as a draft standard. So it's left up to the browser manufacturers to implement them. So some browsers just don't do some of this, and some do it by default. I think the fact that the mobile platforms are pushing this really hard, because a lot of people, they want to develop mobile apps, but they like don't want to learn Objective-C or, you know, Java on the Dalvik, and so this is a good way for them to develop mobile applications using HTML5. So a lot of the mobile browsers support all of this. So, cool. Yep, one more.
W3C's got some smart people. Why didn't they think of security?
They did. So Mike Shima is like one of the guys that I follow over there, who's like pretty bright, and they're aware that this is happening. Part of the problem, as I understand it, is like the cat kind of is already out of the bag. Like people propose stuff and they built it, and then the security people were like, "Oh, what are you doing? Don't do that." So I think they're still working on it and working with browser manufacturers. Of course, like browsers compete on market share. So if a browser can boast a feature, they're more concerned that you get the feature than you get the feature with security built in or on top of it. So yeah, we'll just have to wait and see on that one. Yeah.
Did they build any new sandbox technologies that runs in
There are specs for sandbox for different elements within your HTML page, but the sandboxing that browsers do, say between like instances of browsers or browser tab, that's not covered by HTML5. That makes sense. All right, well, I've taken up enough of your time. Thanks so much. Appreciate it. Thanks for sharing. I love it. Sure. Awesome.
Yeah, it wasn't like just some like you were worried about, you know? No, you're absolutely right.
Awesome. Thank you very much. I really appreciate it. I know. Deep down, I know. Oh, dude, it's like I was offline for like a week, and I was starting to shake, and like your voices at night. I don't want to tweet.